Hello students, welcome to another video for class 8 chemistry. Today we are doing the second part of the chapter carbon. In the first chapter you have read about diamond, which was a crystalline form of carbon itself. Today we are going to do about graphite, which is another crystalline allotrope of carbon, which is generally dark, grey and lustrous. All of you have seen graphite in your pencils. It has high melting point and it is also a good conductor of heat and electricity. And it is because that carbon is having a special arrangement is there in graphite of carbon, that is, it is bonding with 3 covalent bond with other carbon atoms, and hence there is one or the fourth electron which is free and which helps in carrying the electrons and the electricity. So carbon is used as an electrode because it is a good conductor of electricity, and also it is insoluble in most of the solvents, so it doesn't react very quickly with the other chemicals. It has a lead structure, and because of that it is used in the pencil leads, and it can easily slide off and mark the paper grey. It is also used as a dry lubricant in machines because to keep the various parts of the machine frictionless and to help in the easy movement of the parts of the machine. It is also used in making the synthetic diamonds. Now when we talk about the structure of graphite, there are a layered structure you can see in graphite. The carbon atoms are arranged in flat sheets, you can see, of 1 atom each and thickness, and the carbon atom is attached to the 3 other carbon atoms, forming a sheet of interlinked hexagons, you can see. And similarly, a carbon has 4 valence electrons, as you all know, and in graphite each carbon atom is covalently linked to other 3 carbon atoms rather than to the 4, so leaving the 4th electron of the carbon free. And this free electron, which is the reason for the electrical conductivity of graphite. Now the graphite contains layers of carbon atoms held together by the weak forces of attraction, and therefore the layers are very slippery and they slide over each other, which makes the graphite soft, and it can be also used as a lubricant. Also, a single sheet of carbon atom is called graphene. Now talking about the next carbon atom, that is fullerene. Here you can say that fullerene is also another crystalline form of carbon which has either spherical or cylindrical shape, and each molecule contains around 30 to 900 atoms of carbon in it. So if we talk about the spherical fullerene, the Buckminster fullerene is a spherical and hollow caged carbon atom where 60 carbon atoms are joined together, and it is spherical or like a football where 20 hexagonal and 12 pentagonal faces are found. It's also called the buckyball because it is named after Mr. Buckminster, and also sometimes we write it as C60. Now when we talk about cylindrical fullerene, it is arranged in the form of a hollow cylinder, and also they are known as a carbon nanotubes. Now if you talk about the properties and uses of fullerene, fullerene is such a compound which is also, like some of the compounds of fullerene, are good conductors of heat and electricity. They have a very high tensile strength, that is, they don't break easily when they are stretched and all. And the uses is that it is used in the drug delivery systems, like in the particular parts of the body the medicine is reached with the help of fullerene, and it is also used in the treatment of tumors. It is used as a cosmetic and in surface coating. Also it is a good antioxidant, and sometimes it is used as superconductors and also as lubricants. Now moving to the next part of the carbon, that is the amorphous form. Diamond, graphite and fullerene are the crystalline form. They have a particular crystal shape. But when we talk about amorphous carbon, it consists of the charcoal, lamp black, gas carbon, coke, coal. They don't have a crystalline structure. Their arrangement is a very random kind of arrangement, and they are dull and easily they break. Talking about coal, do you know, children, like coal is a thing which has been made millions of years before. Like over time, it is believed that the animals, plants and all, they got buried under the soil, and for many years without getting proper limited supply of oxygen was there, almost absence of oxygen was there, you can say, and slowly the matter found in the plants and animals, they got converted into this black or brown color solid, which is now called the coal. So as the time moves, the carbon content, it increases, and it is also called carbonization. And the slow and complete conversion of this plant material, mostly which has turned into coal under high pressure and temperature, is called coalification. Now if you see this one picture I have put of like a soil layer, so if you go deep down into the soil, the more innermost is the anthracite type of coal, which is the maximum coal carbon content is present in this coal. Above it is bituminous, then lignite and peat. Peat is just containing around 50% of carbon, you can say, and it is quite spongy and porous, and it is used as fuel, you can say, for cooking purpose. And lignite is just like when peat gets compressed little more, it forms the lignite, which around has 70% of carbon, and also it is used for preparing electricity. Then we have bituminous, which is a very light, with time and more pressure of coal, you can say lignite is converting into bituminous coal. This form of coal is dark colored, and around 80% of carbon is found in it. It is used as fuel in power generation and also for making coke. When even more pressure is there, we get the anthracite form. That is, the lignite and bituminous coal, they are converting to anthracite with about 85 to 90% coal, and they are also black, and their calorific value is more. Calorific value is nothing but the amount of heat which is released during burning of 1 unit of coal. So it has a very high calorific value, making it very good for use as a fuel. Also, it is a hard coal, we can say, and it's rare and expensive too. If we talk about the uses of coal, coal in general can be used as a fuel in the production of coke, in the generation of electricity, in the compounds like benzene and naphthalene preparations also, which are containing a large amount of carbon in it. So before we start studying about coal, here you can see that charcoal, when it undergoes destructive distillation, it forms different kinds of charcoal. Let it be wood, bone, sugar, and so on. And the process of breakdown of this organic compounds like wood, bone, sugar, and on heating in the absence of air, when they are forming the compound, the organic substance, that is the charcoal. And the process of breakdown of this organic compound in the absence of air is the destructive distillation process. Now the sources can be anything, as I told you. It can be wood, it can be your charcoal, sugar charcoal can be formed, bone charcoal can be formed, and all are having different uses. When we talk about destructive distillation, there are different products formed. Like you can see, if I do the destructive distillation of coal, then I get coke, which is used as a clean fuel, and in industries and also in the extraction of iron. And coke is like a solid residue, you can see, which is left after the destructive distillation, and it contains around 98% of carbon in it. Then comes the coal tar, which is like a liquidy mixture of carbon, you can say, which is used to prepare organic compounds like benzene and phenol. It's used in the road constructions and making of plastics, etc. Then we have ammonical liquor, which is an impure solution, you can say, of ammonia, and this is used for nitrogen fertilizers preparation. And there is a gas, a mixture of hydrogen, carbon, carbon monoxide and other gases, which is called the coal gas, which is commonly used as a fuel. But nowadays it's replaced by the natural gas, as coal gas pollutes the air, you can say. So when we talk about wood charcoal, Now this wood charcoal is obtained from the destructive distillation of wood. So destructive distillation is what? Without the presence of air, we are heating it. So it turns into a grey, black, porous and a brittle substance, which is the wood charcoal. You might have seen wood burning and how it forms pores on it. So that pores help the wood to float on water also. It is a bad conductor of heat and electricity, but a very important feature it has it can absorb the gases etc. on its surface. So when we are talking about adsorption, it is actually meaning that it can take it on the surface, not completely absorb it, but on the surface it can absorb. So that's called adsorption. Also it forms the activated charcoal, which has a very good adsorption capacity. So you will see that wood charcoal, again, it's used as a fuel in the gunpowder, in decolorizing agents and all. When we talk about bone charcoal, then again you can understand that it's by heating the animal bones in limited supply of air that we get the bone charcoal. And here it contains around 12% of carbon and some calcium compounds also. These calcium compounds, they can be easily dissolved in the acid and filtered, and you can get the black powder, which is called the ivory black. Now bone charcoal is again used as a decolorizing agent, as a black pigment in the paintings, and to refine the crude oil. Then we talk about the sugar charcoal. So it is again one of the purest form of amorphous carbon, and it is obtained by the destructive distillation of cane sugar. So here you can see the formula of cane sugar, C12H22O11, which on heating gives us 12 carbon molecules and 11 water molecules. So this carbon is a sugar charcoal. This is again used as a decolorizing agent, in the reducing agent to extract the metals, and most of these charcoals are used in making masks to absorb the harmful gases, and in water purifiers because of their particular properties. Then let us discuss about the lamp black, or the soot, or the carbon black as we call it. It is prepared by burning the carbon rich compounds, as you can say tar oil, kerosene oil, paraffin, naphthalene, petrol. All these, when they are burnt in limited supply of air, it forms a lamp black or the soot. And when this smoke is allowed to cool on a surface, generally it is depositing as a lamp black or the soot, which is used in the manufacture of printers, ink, because of its color. It is used in shoe polish, carbon paper, typewriting ribbons, in black paint and varnishes, and also in making the kajal. So here you can see a wall. Because of continuous burning near it, it has formed that soot. It has deposited as a velvety layer over the wall. So with this, I am very sure, children, now you have understood the difference between crystalline and amorphous forms of carbon. If you know any more uses of carbon, please write it down in the chat box below. Thank you for watching.